We're back with another Golioth Labs segment, and we're going to be having Alvaro show us how he has developed CircuitPython to work with the Golioth cloud and pass messages back over MQTT to our servers and interface with some CircuitPython hardware he has. What are you going to be showing us here today, Alvaro?
Yeah, you already described some of what we're going to show here. So basically, we're going to be playing with CircuitPython. So it's another platform that we are adding support. It's an experimental support to our platform, but it's something that you can try it out to test with our platform.
Yeah, CircuitPython is so accessible, and I love like how when you save a file on the file system, it's just like that reboot, start over, no big deal. I'm a new program now. Like that's just so it's very friendly in that way.
Yeah, and that came from some of our users on one of our off-C hours. Like, oh, can I have a hot reload thing or live reload on my IoT device? And we're like, you can get from that from like MicroPython or CircuitPython. So we decided to have this experimental support so people can try it out.
Yeah, so now basically they have a device, they're prototyping on their bench, they want to try, maybe they're interfacing to a sensor, and they want to then take that sensor data and push it over MQTT up to the Golioth cloud. What does that interface look like?
Yeah, you mentioned MQTT, but it's what we are using under the hood. But when users are going to be using our CircuitPython SDK, they're not gonna know that it's MQTT because we just
That's great.
Yeah, we put that under the library, so you're just gonna see calls to what to our Golioth services. So you're gonna be accessing lightdb state for managing the state of your device and the real-time information, and sending time series data to lightdb stream, sending logs to our device log. So all of those services have API calls that you can do on our library. But I mean, it's using MQTT under the hood, like you said.
Sure.
But you don't need to know it.
Yeah, I guess I think about it because some of other stuff uses CoAP, the new stuff is MQTT, but it's really like you're saying, it's the functionality. So databasing and configuration or streaming data, like for if you have a sensor, you want to pipe all that state sensor in a time series way. That's really all you need to think about is how to pass your data back.
Yeah, and what we are going to show here is using lightdb state for changing the state of the device and also sending historical information and logs to the cloud. But we have a more advanced demo on our repo that shows using our OTA infrastructure for updating images. So for example, if you have a display and you want to show a different image, you can use our OTA infrastructure because it allows you to not just update the main code from your device, but also sending arbitrary binaries to your device. So you can
say you have a meme and you don't need another meme on your screen. Now you're able to get that done.
Exactly. We're probably going to record a video of the other demo, but yeah, it's basically pushing memes to a display using our OTA infrastructure.
That's great. All right, so what is the hardware we're using today?
Cool. So I'm here on the CircuitPython page where you can download the binary for multiple devices, and the device that we are using today is using from the Micromod platform from SparkFun. So it's the NRF52 Micromod board. So this is the board here. I know that there's a lot of wires here, but this is the main processor with an NRF52. And here what I have plugged in here is a ESP32 acting as a Wi-Fi device. So basically it's communicating using AT commands, and then the host processor, it's running CircuitPython, and it's going to be running our code that are going to be showing here. And some of this is the repo with the CircuitPython SDK. It's under Golioth Labs organization. And you're going to see here that the samples that we created is using the ESP-AT control library, which is basically using an ESP32 as Wi-Fi modem. But we are also planning to add examples using the ESP32 S2, which is supported on CircuitPython, using native Wi-Fi. But this is the first platform that we tested. And then we also tested with the Pi using the same setup. So we have the Raspberry Pi with a ESP32 as Wi-Fi modem and doing the same thing that we're going to be showing here.
Yeah, that is the connectivity piece is always required there. So, but like you're saying, that abstraction through the AT interface to a Wi-Fi modem, and a really cheap one too. I mean, the ESP32 stuff is just so cheap that basically you can add Wi-Fi to just about anything, just with a serial terminal or serial interface, right?
Yeah, exactly. And this one that I'm using is even cheaper, is the ESP32C3 Mini. So
Oh
you can
yeah.
like even like put on your project as the Wi-Fi modem, because it's like one of the cheapest option to add Wi-Fi.
That's great.
And should we dive into code already, or?
Yeah, let's do it. I'm excited about this.
Yeah. So here on the repo, like I said, we have like a lot of samples on different like services from Golioth. So using like blinking an LED, using LightDB state, sending historical information to LightDB stream, using our OTA and DFU infrastructure to like download files to the flash and file system on CircuitPython, and also sending logs. What I'm gonna show here is kind of like a kitchen sink thing that like got like some pieces from each of those samples here, so we can show like most of those functionalities. So let me open here my editor. So I'm using the Mu editor. So a lot of folks that from the CircuitPython community likes to use this one. And this code here is based on one of those samples here. And you're gonna see that all of these samples have like a secret file and also a code, which is like the main firmware for the device. And on this secret file, I'm gonna open mine here. You have to put like the SSID to connect to Wi-Fi, and also the credentials to connect to Golioth platform. So the first thing that I'm going to put here is the my guest Wi-Fi credential here, so the device can already connect. And now we're going to provision a device on Golioth Cloud so the device can connect to our platform here. So I already had like a device created here, but I'm going to provision a new one here so we can do some live coding and live demo. So let's create here, put a name on this device here, CircuitPython NF52. And let's remove this thing here, but let's leave the rest like for the platform to create the PSK ID and PSK here.
Yep, and if people don't remember, PSK ID and PSK is basically like a username password. There's an article on the blog about it as well. But that's what you need in order to then validate this device, this specific device, onto the network, so that it knows, okay, it's the Python CircuitPython device that's trying to talk to the network using these credentials.
Yeah, perfect. And the cool part about CircuitPython is that like we were mentioning before, after I hit save here, the device is already gonna like restart and run our code here, because basically every board is supported by CircuitPython. I already hit save here, and so it restarted. It's connected to Wi-Fi modem. But every board opens up as a thumb drive on your computer, like a USB drive, and you can like just put the files in there and etc. And I ended up like skipping one part here, but to add our SDK, you just need to like get the SDK here, download the zip file, and copy this folder here to your thumb drive. So you're basically gonna have this. Let me open a new one here. You're gonna have like this lib folder here. So you just copy like the Golioth library inside here. And in this case, as we are using the ESP-AT control here, I also copied this library inside here. So
I'm just imagining like C programmers everywhere weeping silently as they see this. They're like, that's how you get libraries in.
Yeah, you just copy and paste. And also like Adafruit do a really good job of making things like easier for users. So they provide what they call CircuitPython bundle. So you can just download that zip file that comes with like a lot of libraries, or basically all the libraries available out there that they officially support. And you can just like copy this whole folder here to your CircuitPython board, and you're gonna have like all the libraries available there. So you don't need to worry about that. But for now, we're optimizing here and putting just the code that we need, which is the Golioth library and the ESP control. So sorry for skipping that part. But while we're talking here, the board already connected to our platform. So it connected to Golioth and said hello here with the name of the board that we gave there, because it's using the hello endpoint from the platform, which is available on all the gateways. So basically, we call it here client.listen hello. And also, we start to listen to LightDB on a given state here. So we're going to get it on a given path inside of it, which is to listen for the LEDs. And then we set up this callback function here, which is listening for messages on LightDB changes are coming through. And then if this path is inside the LED, we're going to look for key 0 and then change the LED 0 to true or false, to on and off. And you can see here that is all like just using Golioth API. So Golioth setting the socket to use the ESP as the socket interface, and then the client credentials and putting the callbacks here. So it's all like using the same language or like, well, of course it's using Python, which is the language, like but the same philosophy for other libraries, which is to set like a callback and like implement those callbacks to be called internally by the library. And then there's a loop here. Oh, you can go ahead.
Well, I was just the fact that there are all these other libraries. It's this kind of higher level language as well. So now the same kind of thing's going to work on all those platforms that you showed as well, right? As long as they're running CircuitPython, it should be able to run the same code. And then if it doesn't have a Wi-Fi modem on it, you're going to be passing over serial out to a ESP32 or outside a Wi-Fi modem like you're doing.
Yeah, exactly. And then what this code is doing here is to every 60 seconds or every minute in this case, it's posting temperature data. And in this case, I don't have a particular sensor connected to my board, but I'm getting the CPU temperature just for testing. And here we are sending data to LightDB stream on the temperature path, and also setting the current state of the device on LightDB state on the /CPU/temperature. So here, if we go on the platform, we can see here the data on LightDB state here. It's updating the CPU and temperature, but we can also go to LightDB stream and see the data points arriving here. Let me put the last, change the timestamp here. Oh, I'm doing an aggregation here. It's a leftover from another demo. So I'm also like getting the temperature, calculating the average on the hour here, but we can change here too. Let's not do an aggregation for now. I'm gonna remove this.
That's good. You're showing other capabilities using the query builder.
Yeah, but those are the data points that the device already sent. And also the
just so people aren't worried that we're not taxing the devices terribly here. Alvaro lives in a very warm location, so the ambient is actually pretty warm there too.
Yeah. Other thing that is showing here is our logging infrastructure. So every time the device is sending data, is sending a log of type info. And we can have like different log levels. You can see here from the sample that you can send like debug messages, warn messages, and other message types. And it's all here on the sample code, like how to send different types, like log debug, or if you want to send like extra information, in this case, sending like the modem version. So let's send this here to add like some extra debug information. So when the device connects to our platform, we're gonna send a log. Let's say that it's a debug message to say that it's connected, and we're gonna send the ESP82 version here. So hit save, it's reloading, reconnecting again. So this is really good for doing a prototype. So CircuitPython have like a lot of libraries available for different sensors, and different modules that you can use. So this is we're really advertising this in the lack of a better word to use as a prototype platform, because it's really good for them.
Yeah, over the holiday, we recorded a past video about the Arduino SDK. That's another great video to check out. I was using that as just like, oh yeah, it's faster prototyping, and now I look at this and I'm like, this is even faster prototyping. And it's kind of a spectrum of what you might want to use on a final product. You might want to so a lot of our examples are built on top of Zephyr. We might support other RTOSes in the future. That might be something you want to deploy long term. But like Alvaro saying, with like starting from kind of getting started quickly, trying out different sensors, using supported libraries that are out there. This is a really, really great way to start, I think, and it shows all the capabilities of the platform as well. And then you might want to scale up later and try Zephyr, try Arduino, try whatever else is out there.
Yeah, and even if you change like the RTOS that you're using, you're going to be accessing the same services. So that's the language that we always want to keep up. Like you're not going to be like interfacing with an MQTT broker or with a co-app. You're going to be interfacing with services that you need for your IoT project. So that's the important part for us. And here you can see the debug message with the ESP80 version here that we just sent as a debug message. And we can go and like filter here on the logs, get just like the debug messages, and see my ESP80 message here also coming from my CircuitPython device. So maybe we can also show like LightDB state changes here to show like the downstream data change. So I can go here to LEDB and add the LED path, and then change the LED to on. So my LED 0, and then I'm gonna hit submit, and there you go. It receives the LED true. And it's gonna be hard to show on camera, but there is an LED here on the module that is on now.
Yeah. That's great. That's great. And so like you're using that the carrier board from SparkFun, and it's got that NRF52 micro mod in there. Then prototyping with the next sensor, you can drop that on there, hit save, and start pushing stuff to Golioth. Same kind of things there, where you're going to be able to just try a lot of sensors and try a lot of things quickly using the CircuitPython methodology, I think.
Yeah, exactly. Like I can test like different architectures. Maybe I can put like an STM32 processor here, and then this
if you could find
board here. Yeah, you can find it. And I don't have one, by the way. I have a SMD51 for the micro mod, but I don't have the STM32.
Yeah.
They have like the quick connector, so you can connect like different sensors. And I have the other micro mod, which is the weather station that already have like a bunch of sensors built in, and all of them are supported by CircuitPython. So it's like you can get like one board and test like a lot of different things on it. And yeah, and like just here on this video, we managed to show like most of the services that we have here available for like the device state, the historical information, and also device log. So this is really powerful because we can just get started like really fast.
Yep. Yeah, I think one of the most frustrating things is, in the IoT space, like getting to Blinky is often many steps. And now it's already collapsed down to basically one step, and then adding a sensor is just another additional step. So now 2 steps and you're streaming data, and that's what most people care about anyways. They just want to see what data they can push back to their other elements, maybe a visualization site or an app that they're trying to build or something like that.
Yeah, exactly.
Awesome. Well, Alvaro, thank you for showing this. We'll have hopefully more Golioth Labs stuff in the future. This is enabling more developers to get more stuff out in the world quickly. And for that, we really appreciate all your hard work on this.
Yeah, awesome. And yeah, I'm going to be here for more demos, maybe to show the memes being downloaded over the OT infrastructure.
That's right. Memes on the way.
Yeah.